Hello, in this video we will be learning about optimized KNN, that is KD trees. Time complexity of KNN is OND, where N is the number of data points and D is the number of features. When N is very large than D, we can approximate the time complexity to be ON. But still, it is alarming. We want to make it O log n. Worst case time still will be equal to ON. KD trees are not an alternative to KNN, but rather a tool to improve its efficiency by optimizing the search process. They provide a structured way to store and search for data points, making the nearest neighbor search in KNN significantly faster. Nearest neighbor search time can be reduced to O log n, especially in lower dimension. Still suffers from the curse of dimensionality. KD trees are a generalization for binary search trees. Every node represents a partition of a point set to the two successor nodes. The root represents the whole point cloud and the leaves provide a complete disjunct partition of the points. These leaves are called buckets of the represented point set. Each level in the KD tree has a cutting dimension, where traversing a KD tree, we cycle through the index to the values list based on the depth of a particular node. Now let us see how to build KD trees with an example. In this figure, we can see we have an example with six different data points, point A, B, C, D, E and F. So first we build the KD tree. So the first point here is A2, 3. So we draw the root node of the tree, 2, 3. Here it is written X, that means at this point our cutting dimension is X. Here it is Y, this shows that the cutting dimension is Y. Once again the cutting dimension at this depth is X, and once again the cutting dimension at this next depth or level is Y. That means between the different attributes the cutting edge keeps on changing. So let us see how this tree is built. The first node is 2, 3. So this 2, 3 is built. The next node is 5, 4. Since 5 is greater than 4, here we will be comparing x. So 5, 4 is on the right hand side. Next node is C, 9, 6. Once again 9 is greater than 2. So it will be in the right branch of the tree. Then here it is 5, 4. At this point we will be comparing y. Now because 6 is higher than 4, so this 9, 6 will be on the right side of the 5, 4. Next point is D, 4, 7. Once again we start with the root. 2 is less than 4, that means 4 on the right hand side. Next here we compare 4, 7 with 5, 4, but since 7 is more than 4, definitely it will be as a right child of this node. So on the next level, because we already have a node over there, so we go to the next level. Now here at this point, our cutting dimension is x. So we will be comparing 4, 7 with 9, 6, but we will be considering 9 and 4. Since 4 is less than 9, this 4, 7 will be left child of this 9, 6. Next is 8, 1, E8, 1. Since 8 is higher than 2, so 8, 1 will be the right child of 2, 3. I'll move to the next level 5, 4. At this point, we'll be comparing 4 and 1. Now, since 1 is less than 4 and this left child is vacant, so we will draw 8, 1 on the left side of 5, 4. Next node is F1, 5. Since 1 is less than 2, so 1, 5 will be on the left side of this tree. So this way we have drawn the tree. Now let us see how do we draw 2D region partitioning for the following points. So here at the bottom we have the x-axis. On the vertical side we have y-axis. First point is 2, 3. So we find this point 2, 3 and draw this vertical line. to make the two horizontal partitions. Next point is B5, comma 4. So this is x5 and this is y4. So this point is 5, comma 4. So we draw a horizontal line. Because we already have drawn one vertical line, then another is horizontal line. Next is C 9, comma 6. We locate the position 9, comma 6. So this is 9, comma 6. Now because this is a horizontal line, so we draw a vertical line to uh, show the partition 9, comma 6. Next is D 4, comma 7. 4, comma 7. This is 4 and this is 7. So this is at this location. So because we already have drawn a vertical line, so this time we will be showing this partition with a horizontal line. Next node is E8, comma 1. We find the location of 8, comma 1 because this line is a horizontal line, so this partition will be shown by a vertical line. Next node is F1, comma 5. So this is the point. Here we have the vertical line to signify the partition. So this time we'll be drawing a horizontal line to represent the partition. So this is all about KD trees, how they are drawn. Thank you for watching.